Hi guys, in this chapter we will discuss the definition of functions, domain and range of a function, and then we will end up with a vertical line test to identify the graph of a function. Now let us start with the definition of relation. A relation is a set of ordered pairs. An example has been given here. See, look at this example. There are the seven ordered pairs as given as a collection. Okay, now this collection is representing a relation. Let us express the relation in a different way. Collect all first elements and set x and all second elements set y. Look at this first element. 3 is a part of x, minus 1 is a part of x. Again 3 repeats, so do not write 1, 2, again 3 repeats, we will write 4. So there are 5 elements in set x, and collect all the second elements to the set y. 5, 0, minus 3, 5, 0, minus 3, minus 4, again minus 3 repeats, 0 repeats, 5 repeats. So 4 elements in y. Now we can see how the relation is working. The element 3 in x is mapped to 5 in y. So this is an ordered pair, the relation between 3 and 5. So the input is x is set of all inputs, and y can be set of all outputs. So okay. Next, minus 1 is mapped to 0, that is given the second pair. Third, 3 mapped to minus 3. 4, 1 is mapped to minus 4. 2 is mapped to minus 3. And 3 is mapped to 0. 4 is related to 5. And that's not the end. We can create 2 to the power here, 3 to 5 into 4, 2 to the power 20 possible relations within these two sets. Okay, let's see this rule. If set A has n elements, then how many possible relations are there on A? If you have a set with n elements, call it A, and you find relation between A and A. There are n elements, 1, 2, 3 up to n elements. So how many relations are there between A and A? That is what given here. There are n elements here, n elements. So A cross A Cartesian product of A and A will have n square elements. Therefore, there are 2 power n square relations possible on A. Okay. Now we will see the definition of function. Function is a special case of relation. The definition of relation will turn to be a definition of function under a condition. The condition is here. Look at this definition of a relation. The first element is allowed to repeat in case of relation, but in case of function we restrict this one. No repetition allowed in the first space. The number in the first space should not repeat. That is the condition given for a function. It means that if you have a set x and a set y, one element in x should be mapped to only one element in y. It should not have two images. Okay, this is wrong. Second image is wrong. So this is the way function is defined. Now we will go to the definition of function. A special relationship where each input has a single output. Example has been given here. You can give different values for x. X is independent variable. You can give different values for x, you get an output. Give x is 1, then y is f of x, y is 1 over 2 for first pair. Give x is 2, y is 1, 2 comma 1. So in this way we can get a number of ordered pairs, isn't it? Here the first element will not repeat because we are restricting. This output, one input will have only one output. Such relations are called functions. Example, you can write plenty. See, y is equal to x square is a function, but if you write y square is equal to x, it's not a function. Give some value for x, give x is equal to 4 here, then y square is equal to 4, y is equal to square root of plus or minus square root of 4, y is equal to plus 2 or minus 2. There are two outcomes. So this is not an example of a function. Okay. Some examples of functions are going to be written here. You can write y is equal to 2x plus 3. It's a straight line on a two-dimensional plane. This is a function, example of function. Y is equal to absolute value of x is an example of function. But remember, x is equal to absolute value of y is not a function. Of course, when I write, we will see some more examples, counter examples, which are not functions, isn't it? You see, x square plus y square is equal to 4 is a circle, isn't it? It may be looking like this one. In the x-axis and y-axis, this is origin. This is a circle centered at origin with the radius 2 units. So this is the circle. This is not a function. Why? Because if you write this one in this form, y square is equal to 4 minus x square, you can give some inputs for x and you will get two different values for y. Two different output will be there. Therefore, this is not a function. So when this will be function, if you write separately, that is y is equal to plus or minus square root of 4 minus x square, still not a function. There are two different outputs for every input. But y is equal to positive square root of 4 minus x square alone with no negative, only positive square root is a function. Or y is negative square root of 4 minus x square. When you separate this one into two parts, each part is a function, but together it is not a function. Okay, because there is a concept of vertical line test. When we draw a vertical line here, it should not intersect at 2 points. It should intersect only at one. It means for every x value here, there should be only one y value. But when you draw a vertical line here, the circle, there will be two y values. So this is not an example of a function. Okay. We will see the vertical line again. Now, if a set A has m elements and a set B has n elements, this is set A has 1, 2, 3 up to m elements, and another set B has 1, 2, 3 n elements. Then how many functions are possible between A and B? Is n, this number n to the power m, n raised to m. There are n to the power m functions possible between A and B. And the notation of the function is given here as f of x, function name, and x is input. Look at this graph. The first one is an example of a graph. You see, every element has only one image. 3 maps to 3, 4 goes to only 8, 4, 7 goes to 4, 5 goes to 8. But in the second graph, you can see 5 has 2 elements, 2 images. You will get one pair 5, 4, another pair 5, 7. It repeats, isn't it? For one input to 5, there are two different outputs. So this is not a function. In the case of function, many to one is allowed, but one to many, one element to many element relation is not allowed. This is allowed, this is not allowed. Okay. In this way you can identify a function. Some more examples. In this graph, look at this one. The set x and y has been given. There is a function between them. This relation is a function or not? X1 is mapped to only one element, x2 gets only one image, x3 many, 1 to many is good, sorry, many to 1 is good, x3 and x1 have same image, there is no problem. X4, X3, they all have single images, therefore this is a function. And check this is a function or not. Yeah, when you collect the set x, the set y, here x has 1, 2, 3, y has only one element 0, all elements are mapped to 0, many to 1 is allowed. This is a function. This is a function. And the next example, a set of ordered pairs. Here the first element is repeating or not, just check. No repetition in the first element. So this is again a function. Next 5, 10, 1 pair, 3, 4, 5 repeats, the first element repeats, so one element has two images. This is not a function. Okay. Next, evaluating a function. A function has been given here, f of x is equal to x square minus 1. So for every input you will get only one output. How to evaluate? Put this value. So you are supposed to find f of negative 5, isn't it? X value is negative 5. So this x should be replaced by negative 5. Wherever x comes in this function, you just replace x by this value. So first one, a will be x will be replaced by negative 5. Negative 5 square minus 1, which is 25 minus 1 is equal to 24. In the case of b, just use this 3b in the place of x. So for b, the answer is 3b whole square minus 1. You can write in simplified form as 9b square minus 1. C, 3 times f of b. So first find f of b. What is f of b? F of b is found by replacing x by b. It is b square minus 1. So what is 3 times f of b? It is 3 times b square minus 1. And for d, f of a plus 3, the variable x will be replaced by a plus 3. So f of a plus 3 is a plus 3 whole square minus 1. This x is replaced by a plus 3. Now you can expand this one by using the formula a square plus 2 into 3 6a plus 3 square is 9 minus 1. When you simplify, it is a square plus 6a plus 8. And finally the e case is first find f of a, then find f of 3 and then sum them up. F of a is obtained by replacing x by a. It is a square minus 1. F of 3 is 3 square minus 1. So when you add f of a plus f of 3, you get a square minus 1 plus 9 minus 1, which is 8 here. 8. So you will get 8 minus 1, a square plus 7 is the answer for E. And next, some more examples of evaluation of the function. I'm not going to solve all this one. A0 is easy, just replace w by e, w by 0 in the first case, w by 2 in the second case, minus 2, 4, these are trivial, isn't it? Try E. A of r plus 1, wherever w comes, replace it by r plus 1. So under square root, w square is replaced by r plus 1 square and write the plus 5. When you simplify, under square root you get r square plus 2 times 1 r plus 1 square is 1 plus 5. When you simplify further, it is r square plus 2r plus 6. Finally, a of negative c, I leave this one to you. Negative c, just replace w square by negative c. W by negative, so negative c square will be c square plus 5, isn't it? That's it. You try the other problems. Here piecewise defined functions given. How to find the values of the function for some given x values. F of 5. Look at this function. This function, the first part of the function is defined for all values of x less than or equal to negative 5. Second part of the function is between negative 5 to 4, where 4 is included and negative 5 is not included, isn't it? Third part is for all x values greater than 4. So keeping this separation of the interval in mind, let us try f of 5. F of 5, where the 5 falls, in which interval this value of x5 falls. X is equal to 5 is not included in the second interval, it is in the first. This is positive 5. Positive 5 is here greater than 4, isn't it? So it is falling in this interval. Now use the x value in this part of the function. There you go. So f of 5 is 5 cube 5 cube minus 4 times 5. You can do it. 5 cube is 125 minus 4 times 5 is 20. This is 105. Next, similarly, try f of negative 1. Where is the negative 1 falling? Negative 1 is in this interval, isn't it? Which is greater than minus 5 and lesser than 4. So it is falling in this interval. So this part of the function should be used to find function value of negative 1. Use here f of negative 1. Therefore minus 1, 3 times minus 1 minus 2. This is minus 3 minus 2 minus 5. F of minus 5 falls in the first interval, so use this one to find f of minus 5. F of 4 is included in the second interval, so use the second part of the function to find f of 4. Okay, try this one this way. Next, I am moving to the concept of domain and range of a function. Unless otherwise stated, the domain of a function is the set of all real numbers for which the function makes sense and yields real numbers. To explain this one, I give one example to you. F of x is equal to 1 over x minus 2. Okay. Here you can give any value for x, you will get a real number output. The output must be a real number, isn't it? So when you give some input value for x, make sure that the output is a real number, not a complex number. Okay. So for that, what kind of values can be given to x? Can we give x is 0? Yes. X is 1? Yes. X is negative 1? Yes, you will get an output if negative 1. A real number output will be the answer. But can you give x is equal to 2? No, because x is equal to 2 makes the denominator 0, that will be infinity. The answer will be infinity. The function is not defined for x is equal to 2. So all these values, x is 0, x is 1, x is negative 1, x is equal to 100, x is equal to minus 1000, anything can be given except the value 2. So the domain, if I want to say the domain in words, all real x values except x is equal to 2. So part of all x values except x equal to 2 is the set, is the domain of this function. If I want to write the answer in set builder form, it is set of all x such that x not equal to 2. Okay, if I want to write in interval notation, it is minus infinity to 2 open interval union 2 to positive infinity. So these all are the domains of this function. It means you can give any value for x as an input, there will be a real number output except the value x is equal to 2. Okay, so all these the different expressions of the domain. Clear? Now the question is, what is the range of the same function? See, if you have a set x and another set to y for a function f, x gives inputs to the function, isn't it? And y will be the outputs. Collection of all inputs, our domain, and collection of all outputs will be the range, and make sure that they are real numbers. Okay, no complex number. So real number includes all natural numbers, whole numbers, rational number, irrational number. You can use even pi as an input. Fine. Let's take some more examples to understand. Okay, some questions are here. Determine whether the given value of the variable is in the domain of the function. Okay, here 3x over x plus 4 is the given function for which x is 0 is allowed input or not. Then if it is allowed, then this is a part of this is inside the domain. Yes, put x is 0 here. 3 times 0 divided by 0 plus 4 gives you 0. 0 is a finite answer. So x is 0 is in the domain. Yes, the answer is yes. The second question number 10 from your textbook. Put t is negative 2 in this function. It is 1 over negative 2 cube plus 8 gives you 1 over 0, which is infinity, isn't it? So there is no real number output. Infinity, for which the function is not defined for this value. Okay, this is not a part of the domain. This is not in the domain. So the domain includes all values of t except negative 2. Clear? That's it. Let us take some more examples. Some other examples are given here. F of x is equal to negative 2x plus 1. You can give for this kind of linear equations, representing a straight line is y is equal to minus 2x plus 1. Any value can be given for x to get an output in real number. So for 36, the answer, so the question is determine the domain, isn't it, of the function represented by the given equation. So for question number 36, all x in R means there are a set of all real numbers, isn't it? You can write set of all x such that x belongs to R is a real number, or you can write from minus infinity to plus infinity, all values of x are allowed. For 36, this is the domain. This is the domain for 36. Fine. Next, let's go with the question number 40. The similar type question just we have discussed. Okay, let's try what is the domain for this one. And if you look at this one, x is not equal to 5, isn't it? X should not be 5. 5 makes 5 minus 5 0, so denominator. So all x in real number are except x is 5, isn't it? This is inverse. In set builder notation, you can write set of all x such that x not equal to 5. In interval notation, these all are the notations, the different forms of domain. In interval notation, you can write minus infinity to 5 open bracket, because 5 is not included, union 5 to positive infinity. Okay, these are the domains. What's the range of this one? You cannot get a 0 here. You cannot get a 0 here because there is no x in the numerator. Now I am talking about range. There is no range in the question. I just want to give one example of range. If there is a 6x here, for x is equal to 0, we can get a 0 here. But there is no 0, it's a constant in the numerator. And there is no value of x that makes the entire function 0. So in the output there is no 0. Therefore the range which is the collection of all outputs y, set of all y, such that y not equal to 0. Set of all y from the real number, so that y not y is output, so we will write in y. Okay, otherwise you can write minus infinity to 0 union 0 to positive infinity is the range of this problem. Okay, fine. Now let's go to find the domain of question number 43. F of x is equal to square root of 4 minus x square. Listen, when x square root is the numerator, in this case square root in the numerator, in the second case square root in the denominator. Okay, square root in the numerator allows 0, isn't it? Inside the square root 4 minus x square, this term 4 minus x square can be greater than 0 or equal to 0, because under the square root we should not allow negative values. Altogether this 4 minus x square must be positive or 0. So just roughly draw a real number for minus infinity to plus infinity, and you know x square is equal to 4, then x is plus or minus 2. So take those two, minus 2 and plus 2 here on the line. Now we got 3 intervals. In every interval check what is the sign of 4 minus x square. In this interval pick a number minus 3. Use the minus 3 in x. Minus 3 square is 9, so 4 minus 9 is negative. Not true, isn't it? So this is not our interval. In the second interval, minus 2 to plus 2, the middle value is 0. So pick the 0 for x, write down is 4 minus 0, which is positive, is good. This interval is good. Third interval, again, you can pick a value 3 here, 3, 4 minus 9 is negative, so this is not our interval. In this interval, the question is, can we include the boundary points 2 and negative 2? Yes, because this is this square root to the numerator. F of x has only numerator. So 2 or negative 2 makes this term just 0. 0 is allowed. So the domain for the problem 43 is from minus 2 to positive 2, both ends are included. Or you can write in set builder form, set of all x such that minus 2 less than or equal to x less than or equal to 2. So this is it. Okay, and we will try 46, and I will give some more practice problems for you to practice. 46. Okay, what is it? The term under denominator, under square root, must be a positive term, and of course we should not allow 0 in the denominator. So 5 minus x must be positive. No, not equal to 0. So in the denominator we cannot allow 0. That is 5 is greater than x. It means x is less than 5. Not the 5 included, isn't it? Therefore, you can write negative infinity to 5 with open interval. This is your domain. All value of x which is lesser than 5 is allowed for this function as our domain. If you give any x value which is greater than 5, the answer will be a negative number. Under square root it will lead to an imaginary number, complex field, right? So this is the domain. Can write all x less than 5. I can give you another example. F of x is equal to 1 over square root of x square minus 9. This is another example for which you find again a domain. Well, this is this square root in the denominator, so denominator should not be 0. We cannot get a 0 in the denominator. Therefore, this term x square minus 9 must be greater than 0. No equality. Okay. And you know x square is 9, therefore x is plus or minus 3. Draw the real line. Write minus 3 plus 3 on the real line. The ends are negative infinity to positive infinity. Now pick some values to check the values of this polynomial. Some number from here, minus 4, put it in this equation, this inequality. X is minus 4, is 16 minus 9 is positive. Okay, good. Therefore, this interval is possible part of the domain. Second interval from minus 3 to 3, pick a value 0 and put in of x. 0 minus 9 is negative, so this is not a part of our domain. And from 3 to infinity, you pick another number, 4, positive 4, and put instead of x. You get again 16 minus 9, which is positive. Therefore, this interval is also included. And the question is, can we include the 3 and negative 3? Negative 3 or positive 3 will make this term equal to 0. Equal to 0 is not allowed. So, we cannot allow 3 and negative 3. Therefore, your domain is minus infinity to minus 3 open union 3 to positive infinity. Okay. This is it. This is the domain of this function. I'll write down some practice problems for you. You can practice. F of x is equal to square root of x minus 10. F of x is equal to square root of x square minus 25. F of x is equal to 1 over square root of x minus 7. F of x is equal to 1 over square root of 9 minus x square. F of x is equal to 1 over square root of x square minus 16. F of x is equal to 1 over x square minus 5x plus 6. For all these functions, try to find the domain in all the three forms, in word form, in set builder form, or in interval notation. That's it. And next we will see vertical line test. We'll take the graph y is equal to absolute value of x. This is a V-shaped curve. Okay. This is x-axis and this is y-axis. You see, when I draw a vertical line anywhere in this graph, here this is x value, this is y value, isn't it? For one x value, whatever x is here, there is only one y value. So vertical line intersects the function f of x only at one point. It should not intersect at 2 points. Therefore, this is a function. But when I write x is equal to absolute value of y, it will be looking like this graph. This is x-axis, this is y-axis. This will be the graph, isn't it? And when I draw a vertical line here, for one x value you are getting two different y values. The vertical line is intersecting the function at more than one places. More than one intersection is not allowed. So this is not a function. So when you look at the graph, you can easily identify whether the graph is representing a function or not. Okay, I will give you some examples here. You see, this is a straight line. As a function. When you draw a vertical line, it intersects only at one point. This line, the line which is parallel to x-axis, still when you draw a vertical line, intersect at only one point. But you know, the vertical line, for one x value, there are infinitely many y values. Y is 1 here, y is 2 here, y is 3 here, y is -1, y is -2. So infinitely many y values for one x value, isn't it? This is not a function. And here, but in this case, here this fourth curve, when you draw a vertical line, it intersects at only one point, so this is a function. Obviously, the parabola to the right is not a function. This is a function. The absolute value, this one is not a function, and the circle is not a function. Okay, so that's it. Thank you very much.